Welcome back. Thank you for joining me again. Today we're going to finish up those 8.3 notes talking about multiplying binomials together. So just as a review question to recall, how do I multiply two binomials? Well, that is where the FOIL method comes in. First, outside, inside, and last. Now, unfortunately, this method does have one little hindrance. If you look in the next slide, if you look right here, well, the FOIL method wouldn't really work, okay? Because here, there's no distinct first, outside, inside, last, because that second polynomial has three terms. So we do something extremely similar to the FOIL method, but we call it the distributive property. It's a little bit different than the distributive property you're used to also. It's what we're going to call it, but don't think about what you've done as distributive. So what we're going to do is I'm going to take that first term, I'm going to take that y, and I'm going to multiply it to everything inside that second parenthesis. So what do I mean by that? Well, I'm going to take y times 2y squared. So 1 times 2 gives me 2. And for the y's, I have an x1 and a 1 there. 1 plus 2 gives me 3. I'm going to distribute that y to that negative y. So we have a negative y to the first, 1 plus 1 gives me y to the 2. Then finally y times 6 gives me 6y. So I take the first term and distribute it to everything inside that second parenthesis. And now I'm also going to do that very same thing with my second term, with that negative 3. I'm going to take that, distribute it to everything inside that second parenthesis. Negative 3 times 2y squared. Negative 3 times 2 gives us a negative 6y squared. Negative 3 times negative y, negative times a negative, is a positive 3y. Negative 3 times 6 is a negative 18. So again, all I've really done is distributed through both terms. The FOIL method actually does this exact same thing. It just does it in a systematic order. Where here, I'm just making sure everything goes everywhere. Once I have this written out, now to the point that I'm just going to look and see, can I combine any like terms? So I have that 2y cubed right here. Well, I don't see any like terms for it. There's no other cubed terms. So that's just going to come down to my final answer. Y squared, so I see two of them. I see a negative y squared here and a negative 6y squared there. So together, that's going to give me negative 7y squared. I see a 6y here and a 3y there. So together, that's going to give me a 9y. Then finally, I see the lonely negative 18 that does not have any like terms to combine with. All right, so that's what this process looks like. And again, very, very similar to FOIL. It just doesn't have the same order, the same acronym, but essentially it's accomplishing exactly the same thing. And this is how you're going to deal with whenever you have a binomial times something greater, so a trinomial or anything like that. This is the process you will use. Now, there's also going to be some word problems where we're going to deal with in this second part. So, you want to create a border of length x around a rectangular skate park, which is currently 50 yards by 20 yards. Write a simplified expression for the area of the park, which includes the border. So, what are we talking about doing here? Well, I have my little skate park, which is 20 times 50. And now, around it, I'm creating this border. All right, that border has length x everywhere. So this new border, well, what's it doing? Well, you can see along the top you have that original 50 right here, but now you also have x and x. So the full length is going to be 50 plus 2x. What about the sides? Well, down the sides, you have that original 20 right there. Now you have x and x, so you have 20 plus, again, oh, I'm sorry, I'm writing that in the wrong place. You have 20 plus that same 2x because of the border. And now what they want you to do is they want you to show you an expression of the new area. Well, again, area, length times width. So we're going to have that 20 plus 2x. We're going to multiply it by the 50 plus 2x. Now, this is just two binomials being multiplied to find this area. So for this, we can still use our FOIL method. So that's what I'm going to use. So we're going to focus on the first terms. 20 times 50 gives us 1,000. Oh, for outside, 20 times 2x. Well, 20 times 2 gives me 40, and then I have that x there. Inside, 2x times 50. 2 times 50 is 100, and then I have the x there. And now finally, last, 2x times 2x. 2 times 2 gives me 4, and then each of the x's is an exponent of 1. 1 plus 1 gives me x squared. All right, now, not only am I going to combine my like terms here, I also want to work on writing this in order. So what I mean by that is I have 4x squared. Now there's no like terms for it, but remember, we like to write the highest exponent first. Now the x terms, 40x and 100x, well, that's going to give us 140x. Then finally, lastly, the 1,000 doesn't have any like terms, so we're just going to put it at the end. And that's how we can represent the area. All right. So moving on to our next word problem. This is a multiple choice problem. And I think I'm going to need some more space, so I'm going to move it like that. A cylinder has dimensions shown in the diagram. Which polynomial in standard form best describes the total surface area of the cylinder? The total surface area of a cylinder is given by this formula right here, where r is the radius and h is the height. All right, so first thing I want to do is, since I have a radius of x plus 1 and a height of x plus 3, the first thing I'm going to do, I'm just going to plug those in for r and h. So we have 2 pi r squared, well, the radius is x plus 1, so x plus 1 squared plus 2 pi r, and again, r being x plus 1, h. And the height is x plus 4. All right, so quite a bit going on here that we need to take care of. The first thing that I want to do is I'm going to notice this squared right here. To make it more obvious what needs to be done, I'm going to take that squared, I'm actually going to write it out. So I'm going to take 2 pi, and what that squared means is you're taking the x plus 1 and multiplying it to itself. So I'm actually going to write that out. All right, so now we have something that looks like that. And I'm guessing you can see here and here, we're going to be using our FOIL method to simplify this. So we have that 2 pi out front. Now I'm going to start foiling. F for first. X times x gives me x squared. O for outside, x times 1 gives me just x. Inside, 1 times x just gives me x again. And L for last, 1 times 1 just gives me 1. I'm going to do the same thing for the second one. I'm going to just leave that 2 pi out front for now. And now I'm going to start foiling. F for first. X times x gives me x squared. O for outside. X times 4 gives me 4x. I for inside. 1 times x gives me x. L for last. 1 times 4 gives me 4. Now, I see some like terms that I can combine. So in that first one, I'm going to combine those two x's. X plus x gives me 2x. 4x plus x gives me 5 of those x's. So now I have it to there. So now it's time. We still don't have anything that looks like one of those answers that we have. So what am I going to do? I'm going to distribute those 2 pi's throughout. So I'm going to take this 2 pi, multiply it to my x squared. So I'm going to have 2 pi x squared. I'm going to take that 2 pi, multiply it to my 2x. Well, 2 times 2 gives me 4. So now I have 4 pi and x. 2 pi times 1 just gives me 2 pi. I'm going to do the same thing on the next one. 2 pi times x squared, 2 pi x squared. 2 pi times 5x, well 2 times 5, I have 10. Now I still have pi x at the end. 2 pi times 4, well this time 2 times 4 gives me 8 of those pi's. So now after distributing that through, looks like I have a big jumbled mess. But I can combine my like terms again. So here are my x squared terms. I'm going to combine those. 2 pi x squared plus 2 pi x squared. Well, 2 plus 2, I have 4 of those pi x squareds now. Turns to my just x terms. I have 4 pi x, 10 pi x. Well, 4 plus 10 gives me 14 of those pi x's. And now I see 2 pi and 8 pi. Well, 2 plus 8 gives me 10 of those pi's. So writing it in standard form, this is what I get. So I need to go back up after doing that and now see which one of my answers fits that. Well, that is looking like option C. So C is going to be my answer. All right, so once again, thank you for joining me. That's going to be the end of this notes video. So make sure you finish writing out all those notes. We will check it tomorrow and then continue doing our practice in class.